Good morning all. Today we are going to talk about real-time software design, which is presented in software engineering topic. So I am Padma Priya and assistant professor of IT in SNS College of Technology. So here we go. So real-time software design. In real-time software design, it is designing embedded software systems whose behavior is subject to timing constraints. A system is said to be real-time if the total correctness of an operation depends not only upon its logical correctness, but also upon the time in which it is performed. So what is real-time systems? System which monitor and control their environment. Time is critical. So real-time systems must respond within specified times, inevitably associated with hardware devices. So in this case, hardware devices means which is sensors and actuators. What is sensors? Collect data from the system environment. Actuators change the system's environment. Here we can see the exact definition of the real-time system. A real-time system is a software system where the correct functioning of the system depends on the results produced by the system and the time at which these results are produced. Soft real-time system whose operation is degraded if results are not produced according to the specified timing constraints. So hard real-time system in the sense system whose operation is incorrect if results are not produced according to the timing specification. Okay, if we use the real-time system, we can get some responses from there. So for collecting that responses, we have used some responses systems. What are all this? It is stimulus. Given a stimulus, the system must produce a response within a specified time. It is a periodic stimuli or aperiodic stimuli. Periodic stimuli which occurs at predictable time intervals. For example, a temperature sensor may be pulled 10 times per second. A periodic stimuli which occurs at unpredictable times. For example, a system power failure may trigger an interrupt which must be processed by the system. So, architectural consideration. Because of the need to respond to timing demands made by different stimuli responses, the system architecture must allow for fast switching between stimulus handlers. Timing demands of different stimuli are different, so a simple sequential loop is not usually adequate. Real-time systems are usually designed as cooperating processes with a real-time executive controlling these processes. So these are all the diagram for a real-time system model. So here we can use the 6 types of sensor and actuators for controlling the real-time systems. So in this case we can use the hardwares. Those hardwares are hardware device or sensor and actuators, and the actual flow diagram for that hardware device. Sensor control processes collect information from sensors and may buffer information collected in response to a sensor stimulus. Data processor carries out processing of collected information and computes the system response. Actuators generates control signals for the actuator. So system design both the hardware and the software associated with the system. Partitions functions to either hardware or software. Design decisions should be made on the basis on non-functional system requirements. Hardware delivers better performance but potentially longer development and less scope for change. So this is the hardware and software designs diagram. First, establish systems requirements, then partition the requirements. In that partition, we have to partition the requirements in 2 types. First one, software requirements, and second one, hardware requirements. In this software requirements, we have to make the decision for software requirements, so software design. In hardware requirements, we have to make a design for hardware systems. So in that case, we have to design the hardware design. So real-time systems design process. First, we have to identify the stimuli to be processed and the required responses to these stimuli. The second step, for each stimulus and response, identify the timing constraints. Third one, aggregate the stimulus and response processing into concurrent process. A process may be associated with each class of stimulus and response. Design algorithms to process each class of stimulus and response. Design a scheduling system which will ensure that processes are started in time to meet their deadlines. The last step, integrate using a real-time executive or operating systems. So here we can see the state machine modeling. The effect of a stimulus in a real-time system may trigger a transition from one state to another. Finite state machines can be used for modeling real-time systems. However, finite state machines models log structures. Even simple systems can have a complex model. The UML includes notations for defining state machine models. Thank you.